This is probably the most ridiculous lab setup you will see in all of high school physics. Okay, let's see if we can understand it. We start with a car battery. Car battery has a red wire that leads it to a rod, and this aluminum rod runs across the table, and the rod points due north. So the rod has a current that goes exactly north. Now, what's this? This is a compass. The compass is above the wire. The compass is above the wire. I don't know if you can see that. Okay, directly above the wire. The compass is directly above the wire. And the compass is on a meter stick, which is supported by this lab jack here, this lab raise and lower thing. Okay, so the current goes through the rod pointing north, and then it goes through this black wire until we reach this set of resistors. 3 1-ohm resistors. Yeah, those are 1-ohm resistors, all in parallel, and then you'll see them leading to an ammeter. So it leads to an ammeter, and then back to the battery. So let's review. From the battery, northward, directly northward through the rod with the compass on top, then through resistors in parallel to try and get as high a current as I can get, and then through the ammeter so I know what the current is, then back to the battery. So I added resistors until I got the highest amount of current that can be measured by the meter, and that is 15 amps. Now it's not actually 15 amps, it's actually 13 amps. So when I plug in the circuit, I see that it jumps up to 13 amps. That's a constant in this lab, so I'm just going to keep that a constant. So what's going to vary in this lab? What's going to vary is the distance between the compass and the wire. I would recommend 5, 10, 15, 20, 25, maybe 30 centimeters. If you try it on your own and the compass moves too much at 5, try 10, 15, 20, 25, 30, maybe 35. That's what I ultimately did, was I started at 10. Okay, so what do? So I set the distance using a meter stick. And then what I do is I'm going to watch the compass. I'm going to plug in the circuit. Ready? It's going to plug in now, and so measure that angle. So independent variable, distance between the compass and the wire. Dependent variable, the angle the compass turns to. Let's see it again. And a constant is the amount of current. So I'm going to write that down. Oh my gosh, I'm just going to tell you right now, between this and the magnetic field in the box lab, I only do one setup, and we do the whole lab as a class.